Hello everyone. In this video, we're going to discuss your program number 6, which is on static and shared libraries. So in this program, we are going to create a static library and a shared library, and then we are going to link these libraries with your main program. So we're also going to see the difference between the output that is generated using static library and that one generated using shared libraries. So let's get started. So here I have a function ctest1.c. So this function has got this file has got two functions, add and sub, which basically takes two numbers and returns the addition, and this it takes two numbers and returns the subtraction. Similarly, I have one more file which has got div and mul function, which returns the division and multiplication of two numbers. So basically, this is to demonstrate the user-defined functions present in different files. So what we are going to do is we are going to create a static library using these two files and then link it with our main program. And similarly, in the next stage, we are going to create a dynamic library using these two files and then link it with your main program, right? So I have a third file here, and this is our header file. As you know, the header file, it contains the prototype of functions, right? So here in mylib.h, I have included the prototype of the functions that have been defined in ctest1.c and ctest2.c. Now, proc.c file contains the main function. So in this function, you can see I've included stdio.h and I have included the header file which is generated by s, that is mylib.h. So here mylib.h is given in double quotes. It means that the system should search this file in the current folder. It's a user-defined header file. It should search it in the current folder. Whereas the one which is provided in angular bracket will search in the system-defined path, the path environment variable. Right? So what are we doing in the main function here? As you can see, we are just invoking these functions and printing the value returned by these functions. The addition of two numbers is %d add, the subtraction of two numbers is %d sub, and so on. So basically, the main function is going to invoke the functions which are there in the library, right? So once these four files are ready, we are good to go ahead. So you can see here, I've included these four files in this current folder. So first, we're going to see how to create a static library. So to create a static library, the command, first thing is we need to compile the ctest1.c, ctest2.c, right? So yeah. So cc-c here indicates that just compile these programs, don't link. Okay. So cc-c, ctest1.c and ctest2.c. The output of these step is the object files. So you get ctest1.o and ctest2.o, the object files, right? So you can see here we have the object files.o and ctest2.o. Right? The next step is to put these object files in the shared library, and the command for that is arcvq ctest1.o and ctest2.o. AR stands for archive, meaning bundle. Create, verbose, and quit, CVQ, and followed by that the name of our static library. The name of our static library is libctest.a, and your the object files ctest1.o and ctest2.o, which have been created in the previous step. So you can see the static library has been created in the current folder. The next step is to link our the static library with our main program. So for that, we are going to take cc prog.c and libctest.a. Okay. So yes. So what happened? So it has compiled prog.c and also it has linked the function call, that is add sub div and mul from the static library, and it has created the executable file. Now I will run this executable file. So you can see the output. The addition of two numbers is 11 and so on. Excuse me, I have not included the new line here. So, but we can see that our program was able to successfully link with the static library. So let's go ahead and create our dynamic library. So to create a dynamic library, the first step is save. So cc-c ctest1.c ctest2.c. Along with that, we are going to include one more option, -fpic. So this stands for position independent code. So it's going to create an object file with a property of position independent code. So the output of this step is same. It's going to create ctest1.0 and ctest2.0. So what's the next step? We have to use these object files and create our dynamic library. And the command for that is this. Yeah. cc dash shared. So you're going to create a shared shared library. Shared library or a dynamic library. They're one and the same. So you're going to create a shared library and -o, meaning the output file name. It should be libc-test.so. So you're giving the name to your static library as libc-test.o. The .so is a convention, shared object. It's a convention given to the the dynamic library. Similarly, for static library, it is .a. So libc-test.so, what should be included in that? ctest1.0 and ctest2.0, which was created in the previous step. So yes, so you can see our dynamic library has been created, right? So what's the next step? To link this dynamic library with our prog.c. And the command to do that is like this. Yeah, it's like this. cc-l, in the meaning the path of your dynamic library is the current folder. Where have you placed the dynamic library? In the current folder, right? So it's in the current folder. This is your program with the main function, and -l stands for link. You have used -lm, -lpthread. Similar way, you're telling your system to link this program with your dynamic library ctest. So although the name of the dynamic library is libctest.so, you can just give it as ctest. So the here lib is a convention to start the dynamic library name with. Okay, but actual library name is ctest. So -l link with your dynamic library ctest, and when I compile this, by default my output will be a.out. I don't want that because I want to compare the size of the output generated using static library, right? If if I simply create the executable, it's going to override that. I don't want. I want to give my output a different name, hence -o dynamic. So instead of a.out, my compiled code will be named dynamic in this case. So now let's see. So here, yes, dynamic executable has been created with the name dynamic. So this a.out is the executable created using shared library, and this dynamic is the executable created using shared library or the dynamic library. Let's execute this dynamic. So yes, we are getting the output, right? So next step is to compare the size of a.out and compare the size of dynamic. Yes, so you can see here, it's opposite of what we have expected. In case of static library, the library code will be part of your a.out, and the size of a.out is expected to be more than your dynamic, isn't it? But here it's less. That is because the code that we have used is a very simple and a very less code, isn't it? So in case of dynamic library, what's happening is some additional commands are included, which is causing it to be a little more than your static library. But in actual scenario, in the real world, wherein we will have hundreds and thousands of functions in the library will be much larger compared to what we have. And there, the size of the library with the static library will be more compared to your dynamic, right? Here, but here, as it's a very simple code, we see this difference. But if we had large code, then you could have see the visible difference. but what do you say, in general, the in case of a dynamic library, the output generated will not contain the library code, whereas in case of static, the output generated will contain the library code. Okay, so I hope you understood this concept. Thank you.